Good evening and welcome everybody. My name is Khari Parker. I'm board member of Engineering Alumni Network. The remarks in tonight's Zoom will be recorded. So if you do not wish to be recorded during this portion of the program, you may turn off your camera. Your participation in this event is consent for recording. We recommend setting your Zoom accounts to speaker view in the upper right-hand corner to have the best experience tonight. We'll begin tonight's ceremony with the presentation by Sharnesha Brentley and Khari Baker, both co-founders of Kankyo. Following the presentation, we'll open the floor for questions. Please note that tonight's presentation is for information only and is not meant to be financial advice. Now, a little bit more on our presenters. Sharnesha Brentley is an avid blockchain explorer, communicator of ideas, architect of experience, and also co-founder of Kankyo. She's an East Carolina University alumna with a background in MIS, sales tech, and blockchain. And since 2016, Sharnesha has focused on helping others understand the benefits of crypto while also breaking down blockchain technology into relatable concepts. Sharnesha is currently focused on payments and financial inclusion in the crypto space. As for Khari Baker, he's an avid builder of technology, a hacker of growth, an engineer of outcomes. Khari is a longtime community member and an activist in the blockchain community. After creating the Ethereum Charlotte meetup in 2015 and participating in the EtherCamp hackathon in 2016, Khari went on to create a program called Kankyo. Now, Kankyo was presented at conferences such as CryptoLena in 2018 for the topic of trusting education. Kankyo provides the best practices for Ethereum smart contract development and training for family, friends, and community newcomers on blockchain basics and safe crypto practices. Please join me tonight in welcoming Sharnesha Brentley and also Khari Baker.
Hello, everyone. My name is Sharnesha Brentley. And Kankyo, what we basically do, we focus on crypto and blockchain education. So that's anything from tech talks, tutorials, webinars, workshops, and onboarding, as Khari mentioned. Smart contract development. So we now focus on Ethereum smart contract development, as well as Binance Smart Chain development and other smart contract development platforms, and also the up and coming DeFi research and cryptocurrency research as well. So what is cryptocurrency? So cryptocurrency in layman's terms is just digital money created from code. Cryptocurrency is an internet-based medium of exchange, which uses cryptographical functions to conduct financial transactions. So cryptocurrency leverages the blockchain to gain number one, decentralization, transparency, and immutability. So the most important feature that I want everyone to focus on today is that it's not controlled by a central authority. And the decentralized nature of the blockchain makes cryptocurrencies theoretically immune to old ways the government controls and interfere with currencies. Cryptocurrency can be sent between two parties via private and public keys, which we will talk about later. And these transfers can be done with minimal processing fees, allowing users to avoid steep fees charged by traditional financial institutions. So again, cryptocurrency is digital money. It's created from code. The cryptocurrency economy is monitored by peer-to-peer internet protocol, and cryptocurrency is a string of data or hash encoded to signify one unit of currency. So everyone is curious about how cryptocurrency started and who actually created it. Cryptocurrency emerged as a side project from another invention, and the founder, Satoshi Nakamoto, who remains anonymous, no one knows whether it's a male, female, or a collective, was the inventor of Bitcoin and the first most important, cryptocurrency, which is the first and most important cryptocurrency. And in his announcement in late 2008, he stated that he was developing a peer-to-peer electronic cash system. So why did he create this electronic cash system? So his goal was to invent something many people failed to create before, digital cash in the 90s. So a new electronic cash system that uses peer-to-peer network to prevent a popular accounting problem which was a double spending problem. So in lieu of the 2008 global financial crisis, this was a way for people to control the money themselves without the banks, without having to rely on banks or governments and fees in their control. So he found a way to build a decentralized digital cash system after many attempts, sort of like BitTorrent or for my generation, like the LimeWire, a peer-to-peer network for file sharing. This decision was the birth of cryptocurrency. And as I mentioned, because of the very popular accounting problem, which is a double spending problem, he wanted to prevent that one entity spends the same amount twice. Usually, this is done by a central server who keeps records of all of the balances. And in a decentralized network, you don't have this server. So you need a single entity of the network to do this job. Every peer in the network needs to have a list of all the transactions to check if future transactions are valid or an attempt to double spend. And this is why cryptocurrency was created. So I bet you're curious about how exactly cryptocurrency works. Khari and I like to use an analogy that's just, super simple. And we like to say that it's sort of like Chuck E. Cheese. When you're going to Chuck E. Cheese, you arrive with your debit card or you arrive with cash. You use the cash to get tokens. When you get the tokens, you use the tokens to play the games. You play the games and you get tickets, and you use the tickets to cash in to get rewards. So in just a simple form, just think of Chuck E. Cheese when you think of how the system works. But a cryptocurrency like Bitcoin, it consists of a network of peers. So you can think of the games at Chuck E. Cheese or a fun place like that as your network peers. And every peer has a record of the complete history of all transactions and thus of the balance of every account. So for example, a transaction that says Bob gives X amount of Bitcoin to Alice and is signed by Bob's private key. It's basic public key cryptography. Is nothing, special at all. That's just the way it goes. After sign, a transaction is broadcasted to the network and sent from one peer to every other peer. And this is basic peer-to-peer technology. The transaction is also known almost immediately to the entire network when this takes place, but only after a specific amount of time when it's confirmed. So that's when you get into miners, and one of the most important thing about miners, which we'll talk about next, is confirmation. So confirmation is critical within the concept of cryptocurrencies, and you could say that cryptocurrencies is all about confirmation and making sure that the transaction is stored correctly on the blockchain. So some key things about cryptocurrency: it has no intrinsic value, and that it is not redeemable for another commodity. It has no physical form, and it only exists on the network, and its supply is not determined by a central bank, and is completely a decentralized network. So as I spoke about earlier, as far as the miners, confirmation is key in cryptocurrencies, and it's all about confirmation. So some of the key properties of being a miner or miners within the ecosystem is that only miners can confirm these transactions. This is their job in the cryptocurrency network. They take transactions, they stamp them as legit and spread them in the network. After a transaction is confirmed by a miner, every node has to add it to its database, and it becomes a part of the blockchain. So miners, again, are responsible for updating the blockchain with new contracts. And every 10 minutes or so, transactions are grouped into blocks and can be mined and added to the blockchain, forming a chain of blocks, hence the name blockchain. And miners are rewarded with newly created Bitcoin for every block. So this incentivizes them to use their computational power and electricity. So here at the bottom, picture in the right-hand corner is an interesting setup, but some people had their miners set up like that. So for this job, as I mentioned, the miners get rewarded with the token of cryptocurrency. So for example, Bitcoins, and it is one of the most important parts of the cryptocurrency ecosystem. It's decentralized and it has no authority to delegate this task. So cryptocurrency needed some kind of mechanism to prevent, one ruling party from abusing the system. So Satoshi actually set a rule that miners needed to invest some work. And this is where they came up with the proof of work protocol. And the proof of work protocol basically just calls for their computational power and electricity to work with a basic algorithm, which is called SHA, S-H-A 256. And that's just a cryptologic puzzle that miners use with computer graphic cards and electricity to solve. So again, one of the important takeaways, aside from confirmation and those miners confirming those transactions, is decentralization. And it is the core principle behind blockchain technology. And it's basically the idea that you can take the power from one central authority and create better and more robust systems, distributing the power to everyone. And blockchains and cryptocurrencies they're merely tools, technical tools and incentives on which we create these centralized systems. So here on the left, you have a centralized system with one server. It's easy to hack. It's easy for one of the parties to go in and change or update, whereas a decentralized system is ran amongst multiple nodes and multiple entities, so that there has to be confirmation on all ends before there is changes. So the blockchain. So the blockchain is basically a method of storing data so that it's unalterable. So for example, and we'll stick to money in this case, in the case of like Bitcoin, the data is a history of monetary transactions, so-called in the blockchain. So every block contains a group of transactions, as well as a special alphanumeric string called a hash. So a hash is essentially a compression of all data in the block that came before it, and changes drastically if any piece of the data is altered. So what they like to call that as well is like immutability. So things cannot be changed within the blockchain. So what you get is like basically a long line of transactions that are very clearly and obviously falls apart if anyone tries to make a change in the history. This is what makes it unalterable. If you made a transaction yesterday and you wanted to, go back and erase it, every single block after the block that you created will have to change. So that will flag the data inside the block that you're trying to change. And now that will try to change the next block, and so on and so forth. So this structure basically allows every individual person in the decentralized network to keep their history of transactions organized and identical to everyone else. So now we know that the distributed database, it's a distributed database shared among thousands of computers. All of Bitcoin's transactions are stored on the blockchain, and blockchains aren't just tied to digital currencies. So 3 pillars of blockchain technology are decentralization, transparency, and immutability. So before Bitcoin and BitTorrent came along, which are BitTorrent is a file sharing peer-to-peer technology. We use centralized services. And the idea was very simple. You have a centralized entity and it stored all your data, and you'd have to interact solely with this entity to get whatever information that you required. Another example of centralized systems is banks. They store all your money, and the only way that you can pay someone is by, going through the bank. So transparency, one of the most interesting and misunderstood concepts in blockchain is the transparency, because some people say blockchain gives you privacy, while some say that it is transparent. So basically, what's so private about it is that it actually hides your identity in a complex cryptography, which I mentioned earlier, which is called a hash. And it basically hashes your address. It represents an address kind of like your home address, but imagine like a bunch of jumbled up characters, maybe about 30 different characters that will hide your identity, but it also gives you transparency when you can pull up a blockchain in a list of transactions, because it'll show you that hash and it'll show you the actual block and the amount of value that's tied to that address. So in one realm, it has privacy, in the other realm, it has transparency as well. And this level of transparency has never existed in the financial system. So it adds a little more, adds the extra and much needed level of accountability required by some of the biggest institutions. So if you know the public address of one of, an individual or a big company, you can simply pop that public address into the Explorer and look at all the transactions that they've engaged in. So this basically enforces honesty, and that's something that we never had to deal with before. And lastly, immutability in the context of blockchain, which means that, again, something that has been entered into the blockchain, it cannot be tampered with. Helps out with, systems as far as like, embezzlement, because you can't really cook the books and fiddle around with any company accounts. So these are some really interesting blockchain use cases. So as I mentioned, something that we work with is smart contracts, and those are basically distributed ledgers, which enable us to actually code and execute when specific conditions are met. Another use case is for the shared economy, peer-to-peer payments. The blockchain opens the door for direct interaction between parties. Crowdfunding initiatives, blockchains take this to the next level as well, potentially creating crowdsourced venture capital funds. And governance, by making voting results fully public and accessible, distributed database technology could bring full transparency to elections. Supply chain auditing, blockchains provide an easy way to certify the origin of products. Time stamping of dates, locations would correspond with product numbers. File storage, decentralized file storage on the internet brings clear benefits. It prevents hacked and lost files. Prediction markets, they pay out according to event outcomes. Blockchains are a wisdom of the crowd type of technology that will no doubt find new applications for years. Intellectual property. So with smart contracts, that comes into play, and you can protect copyright, automate, sell creative work online. This eliminates the risk of foul copying and redistribution. IoT, Internet of Things, smart contracts also come into play when it comes to automating remote systems through a combination of software, sensors, and network facilities. Microgrids, blockchains enable for renewable energy within local areas like neighborhoods. Identity management, distributed ledgers often enhance methods to prove who you are. Having a secure digitized identity will be important as online services continue to evolve. anti-money laundering, KYC, know your customer, improving. Those practices can be a huge potential. Private data management, users will have the ability to manage and sell their online activity profiles in small fractured amounts if they see fit. Land title registry, publicly accessible ledgers can make all types of record keeping really efficient. Property titles are also susceptible to fraud and can be secured on the chain as well. And lastly, stock trading, peer-to-peer trade confirmations become instant. Intermediaries like auditors and custodians get removed from the process. So now I'll just hand it over to Khari to talk about the next thing.
So right now we're going to be talking about the properties of cryptocurrency and in each underlying ability of cryptocurrency, you're going to see how it creates a secure system. The very first thing that we have here is that it's irreversible. So once a transaction goes through, it cannot be redone, resubmitted, or refunded. So it's permanent, which goes back into what Nisha was saying beforehand, how the blockchain is immutable. Another thing that adds on to the security is the pseudonyms. So when we see that the transactions or accounts are not connected to the real world, so everything in the blockchain is a virtual or a digital identity. So it can be created or erased at any given moment. Fast and global. When we look at the transactions of some of the newer projects in the blockchain space, we see that they're doing million to a billion transactions per second. So that's kind of what adds on to it as well for secure cryptocurrency funds locked inside of your key. So we have a saying in the crypto community, if it's not your keys, then it's not your money, or not your keys, not your wallet. So you always want to be mindful of whenever you create an account that you keep your seed phrase written down somewhere that's private to you, and make sure that you use something permanent like a pen, because you don't want to use pencil because it can wear over time. And then number 5, we have permissionless. So you don't have to ask anybody to use it in the system or behind the smart contracts. If you meet the minimum requirement or the threshold for it, you'll be able to activate the smart contract and get your desired result. So next, we're going to talk about monetary policies. So typically when we think about monetary properties, the first thing that comes to mind is the supply. And with our government in America, we print money, but it's not on a basis, but it's approved by the government when and how much. So when we look at cryptocurrencies, we see that they have limits. Some of them are finite and some of them are limited. Bitcoin has a select supply of 21 million coins, and as soon as all of those are mined up, there won't be any more. So when we look at 2, we have the no debt but bearer. So when you look at fiat, it literally says it's a debt note. If you look at the dollar, or if you look at the $5 bill, you can see that it says that it's a debt note. And with crypto, you're not necessarily carrying debt, you're carrying profits from the blockchain, because every block that gets created is meant to be like a prize in a sense. When it first started, and we had things like mining pools coming into play and different things of that nature. So when we look at ways that people typically invest into crypto, this is going to be a guide to show you the important values, or basically the fundamentals So you, as the person making the investment, is going to be the person who values each role of what it's supposed to do. And what you want to do with your crypto is give it purpose. And a lot of times people give it purpose based on the features that it has. So if we look, it says the road right leads to bootstrapping, and bootstrapping leads to making a governance protocol, a contribution ownership, different things like that, because you have rights in the community based on certain coins or tokens. And that typically is centered around utility. Most cryptocurrencies, if you investing into them, you need to make sure they have a value of exchange. So you need to make sure that there's some liquidity behind it. You need to make sure that it has a verified community of people that's been actively using it for a while. And what that does is it helps you understand how to buy and spend in the ecosystem, as well as get potential rewards. And you can see that there are other roles such as toll function, currency, and earnings. And each one of these has a specific purpose that goes into playing a bigger role with the investment. So now we're on exchanges. Exchanges is an important one because we have always had in the past central and decentralized exchanges. But now with the coming of cross-chain bridge and cross-chain platforms, we have hybrids now. So when we look at centralized exchanges, those are going to be your platforms that have the mandatory AML and KYC in order to use the platform. With the decentralized exchanges, you're going to see that they often just want you to be able to have a decentralized wallet and be able to connect to the platform itself and be able to just have funds, and it'll be able to either swap or farm or whatever you want to do with your coin. And then with the hybrids, it's basically a combination. It might have the features and the accessibility of a decentralized platform, but as you go deeper, they might need a KYC feature in order to allow you to boost your limit and different things like that. So right here, there are two different types of wallets. We're going to be talking about cold storage wallets, which is the Treasure on the right. And then we're going to talk about your hot wallets, which are basically anything that's online or that's an app, something that's decentralized. So on the left, we have what looks like appear to be Exodus. So Exodus is a pretty good beginner wallet to invest in, or just be able to hold other cryptos on. I've been using them for about three to 4 years now. As a growing veteran, I see the use and keeping great fundamental apps. So this is something that I recommend just because of also the security. Trezor is really well to have, especially if you're operating with crypto. If you're going to be new to crypto, you always want to be able to keep a good bit of funds off of the exchanges, just because typically when things happen, you won't be able to withdraw or there might be some complications. So also going back to the centralized and decentralized exchanges, the centralized exchanges typically have a harder time of being able to pull out funds, just because when you give your crypto to centralized platforms, they become your custodian. So that's something that you also want to be wary of as well. So this is a quick example of what a public key and a private key, how they interact, or basically a visual of representation. So your public key is going to be what you're able to share and what you have to share, and most times in order to receive funds. And you won't never really see your private key being as visible as your public key, but when you send it, that's basically the communication between the public and private key to make the transaction happen. So the major cryptocurrencies right now are Bitcoin, Ethereum, Tether, Doge, and Binance. Doge has been growing in popularity as of late because it's the coin of adoption of the year for right now, until there is something more popular than Doge. Currently, more people in the United States know more about Doge than ETH. And I think that shows that there is a lot of growth for the community, but there also needs to be a lot of education, just because when we look at utility and smart contracts and other features of different coins and protocols and things of that nature, we got to be able to understand the future of the coin so that we don't just invest off of speculation. So the evolution of cryptocurrencies relies heavily upon what's known as the meta. The meta is basically the current trends or innovations that everybody in this space heavily relies on as far as usage, incentive to try new products or services or invest in new coins. So the recent meta of now is DeFi, which is decentralized finance, and it's been given the name of future of finance, just because there's been a lot of adoption within the last year and a half into things such as stable coins, liquidity pools, yield farms, and different things of that nature. So speaking of stable coins, the central bank digital currency, which is the CBDC, was created by Circle, partnered with Coinbase to basically test out a stable coin for banks. And they've been able to have some success because they were able to find some legitimacy for it. And as we continue to look at liquidity pools and future of finance and DeFi, we are going to probably see a lot of central banking digital currency. So with the evolution of cryptocurrencies coming from DeFi, another important topic to talk about are dApps and NFTs. So your dApps are basically apps, but for the world of Web3, which is the new internet per se. So blockchain is, I want to say, past the point of where we've had the AOL experience where you had to wait for dial-up. We're currently approaching where we're hitting 5 speed, about to hit 5G. And when we think about the leap from that, that's really important, especially for the advancement of where we're going to be going in the future, especially with things like NFTs, which are being heavily adopted by celebrities and athletes and people of all shades and different backgrounds. You want to be able to think of NFTs as basically your collectibles. Music is turning into NFTs. You have land being able to turn into NFTs as well. So it's a real broad spectrum of what is going to be encompassed by NFTs. So Ethereum is really important to understand because they are kind of the backbone of the decentralized finance. And a lot of beginning DeFi projects started out as ERC20 tokens. A lot of coins that might be big and mainstream now typically had an existing form as ERC20 and basically forked off and created their own network. So Ethereum had the goal of being the world computer, and they haven't necessarily let me down in as far as any innovations they've been doing. They released their first computing language, which is Solidity, around 2016, and then they started working on Viper, I think, in around 2018. And Viper is basically the Python for the blockchain. So the blockchain currently has a front and back end language for it as for smart contract development. And where I think they're going to be going in the future is going to be really big, just because they recently released the ETH 2.0, which was able to help make prices and technology where it is now to get basically a whole lot of hype.
All right. Thank you, Sharnesha and Khari, for the wonderful presentation. We're now going to open up the floor for questions from the audience. At this time, I'm going to pass it over to Heather Medina. She's going to help facilitate the question and answer session for us.
Thank you. We invite guests to submit their questions to our panel by raising your hand or submitting them to me through the chat box. You can, to raise your hand, click the participants button at the bottom of your screen and use the raise hand feature. When it's your turn, you'll see a notification that says the host is asking you to unmute. At this time, you can unmute and ask your question. And when you're done, please remute yourself. We'll attempt to answer as many questions as possible. We have about 15 minutes remaining for questions. Just give everybody a minute to formulate their thoughts. Okay, I have a question coming in from Jeremy.
Hello, and thank you. I have a couple of questions, but I'll just ask this one first. So I understand that the miners have to approve the transactions for them to be complete on every peer-to-peer network. What happens if a miner's storage capacity is maxed out and they're unable to receive any more transactions and they're not able to approve it? Would that shut down the system in any type of way? And if so, doesn't that make the system centralized as opposed to decentralized?
That's a great question, Jeremy. And to answer your question, one miner going down will not take out the whole spectrum of the nodes that are being ran. So what happens is a lot of times there are nodes, and the nodes are take a good bit of time to set up, but once they're set up, they're basically set up. So you as a miner, you're tapping into the node. So you being removed from the network just means that you won't have that opportunity to receive that block that initially gets mined. So there are different protocols. So Bitcoin is proof of work. So that's why miners are essential backbone to Bitcoin, because that's how distribution works. Other coins and other tokens might use proof of stake, which is POS, or they might use delegated proof of stake. And as we keep evolving, we're finding out different ways to not necessarily use up a lot of space. So things like liquidity mining, so by being able to make pools that goes into coins that do proof of stake, there are different mechanisms that you'll be able to do some research on when you look at the holistic form of mining. But you being able to not be rewarded based on lack of space will not deter the whole network. So the nodes basically help you stay decentralized, basically because everybody has to plug into the nodes. Did that answer your question?
Yes, that did. Thanks a lot.
You're welcome.
I have a question in the chat. Why does the price for cryptocurrencies such as Bitcoin fluctuate so much?
Price is structured by volatility. Volatility happens based on popularity, different things such as, let's say, Elon Musk saying that he wants to be able to accept Bitcoin. A lot of people who may or may not necessarily have bought Bitcoin before definitely will buy in just because they know that there might be speculation behind other people wanting to purchase a Tesla with Bitcoin. So when you seen that he wanted to not take Bitcoin because of the energy uses, that's when we had that big incline, just because a lot of people was able to see that as an opportunity to sell because of negative press. So price is always going to be based on speculation, just because volume is never consistent and activity is never consistent. So that's what you always want to be mindful of. One thing I will say, and it's not financial advice, Bitcoin is timestamp technology. So anytime that you see it at a certain point that you feel like is going to be low to you, just invest whatever you can into it to solidify your position in it. So I want to take everybody briefly back to last year when there was actual, I think, like 3 to 6K Bitcoin around this past halving, and Bitcoin crashed, I think, down to around 30,000. So that kind of just puts things into perspective.
Let's see. Got quite a few questions coming in. The mining process is notoriously computationally exhaustive and not necessarily energy efficient. Do you have any inclination on the future state of mining? Are there energy efficient mining processes in the works or in the pipeline?
So, as Khari mentioned earlier, liquidity pools and proof of stake, which is an Ethereum mechanism, that is another resource for mining. So the difference between that and proof of work, as far as using your computational power, is purchasing cryptocurrency. And the cryptocurrency that you do have, what you will actually do is stake that. And staking the cryptocurrency is basically submitting the amount of cryptocurrency that you have, just like you would use your graphics card or your computational power, to something called a liquidity pool. And what that does is it allows you to confirm transactions just as a miner would using computational power, but you're using the power of your cryptocurrency that you purchase, which is essentially energy efficient, and you're not using electricity in a proof of work protocol.
Here's another question. How do you cash out your earnings once you decide to sell?
That's going to be based on the platform that you're currently on. So you want to kind of look at what platform you're on. If you're on Coinbase, they're centralized, so they have a specific procedure process. If you're on Robinhood, they're centralized, so they have a particular procedure and process. So anytime you're looking at selling and being able to take profits, always make sure you have a decentralized wallet like Exodus, and Exodus is EXODUS, and they're typically going to be able to allow you to put your profits, if you need an address to put them on, that's safe, so you can actually keep hold of your profits. A lot of times people are stuck with having crypto they didn't necessarily want because they wasn't able to sell it properly.
People are reading, is there a, Ray says, I read there's a cap on the number of Bitcoins. If so, how close are we to the cap?
So the cap is expected to be happening around 2040. That's when the 21 million Bitcoin will be mined. The reason for that is because there are things called halvings, where every 4 years, Bitcoin will cut its supply in half. So we recently just went through a halving in 2020. We're going to have 3 this decade. The first one just happened last year. The next one is 2024, and the one after that is 2028. So by being able to look at the halvings, they're going to keep cutting supply for as long as possible, but that's going to all the way be ran up around October 2040.
And to add, so we're the 89% of Bitcoin is already circulating, and the current number is 212 Bitcoin that are in circulating supply out of the 21 million.
We have a question along a different line. Is this something that is being explored? Will cryptocurrency be impacted by quantum? And is this something people are thinking about?
Yes. So around 2018, we were actually talking to people who were trying to put it in nanoscience as well. So when we look at the limits of where blockchain technology can go, it's definitely being pushed to maximum efficiency, and that's going to take as much innovation as possible. So that's kind of like the short answer for that.
And someone had a question a little bit ago about what are the best apps? Do you recommend any?
I use Trust Wallet, so that's a good one. Nisha, do you have any ones that you would recommend?
So Trust Wallet that's a good wallet, but I guess just for research or speculation, I like CoinGecko or CoinMarketCap, because what it does is it gives you a wide overview of the cryptos, their exchanges, the market cap, 24-hour volume, gas fees, NFTs, and just a whole overview of the market and news if you're just looking for information. So that's a great application. And then you have your decentralized wallets, like he said, Trust Wallet, and then you have in Exodus, and then you have centralized wallets in exchanges all into one. So that's your Coinbase, things like crypto.com, Binance USA, which there are restrictions around, where you're located. So that's pretty much it.
Let's see. Are the transactions tracked?
Yes. Every blockchain transaction is tracked on the chain, and you should be able to see the transactions on what's known as the Block Explorer. So Ether Block Explorer is called EtherScan. There's also Binance that has its own Block Explorer. So if it has a chain, then it also has an explorer to be able to see the transactions
on. Once the cap is reached, and assuming demand is held constant, what is going to be done to keep pricing of the coin from skyrocketing purely based on scarcity?
That's the thing. once it reaches its full cap, that's when all bets are off. And that's why so many people are viewing Bitcoin per se as kind of like the philosopher's stone, just because as an asset it can hit 1 million, it might hit 100 trillion. We never know. So that's kind of the anticipation of why people are putting high bets on it. And because of that cap, Ethereum wanted to become the world computer to be able to create an infinite amount of tokens because of the foresight that you'll need once you actually hop in to the crypto community and start using some of the technology.
And how does this technology affect Main Street? I think the question is around those that don't invest in crypto. Why should they be inclined to invest in, and I guess explain it to us in layman's terms?
When I think about opportunity, I think of when the debit card first got introduced to the world and everybody wasn't necessarily hip to why it was going to be such a great financial innovation. And when you look into everybody's wallets nowadays, you see that there's multiple types of payment cards. Like companies have different type of payment cards and payment structures and different things of that nature. So when we look at Bitcoin blockchain and when we look at crypto, that's just a chance for you to say, hey, I have a piece of the new financial infrastructure that is going to be global. So it just doesn't stop here in America. It doesn't just stop in Canada or Mexico. It doesn't just stop in Europe, Russia. It's being able to create a whole different type of infrastructure. So 2018 was really big in that regard because a lot of work was centered around creating accounts for refugees and people who were unbanked. So being able to bank the unbanked created a great infrastructure to why, as far as the technology that's behind it or just the speculation behind it, there are other features and other things that you'll be able to do with Bitcoin besides financial. So I just like to always let people know that having it now might mean a potential scholarship for your kids if you choose to have them one day, or if you already have them.
Also, besides like Khari mentioned, besides any financial like inclination, there are other use cases. So for example, we have the opportunity to work with healthcare systems, and they were trying to figure out just transparency within a breast milk bank for mothers who couldn't produce breast milk. So there are companies in that nature that are trying to find transparency or use the blockchain technology that you can invest in or be a part of if you have any, intellectual capital that you can use in those areas. So that's another way to invest if we're not just talking about financial loss.
Here's one. Since transactions are tracked, how does cryptocurrency provide confidentiality for criminals?
And that's where the pseudo-anonymous comes in. So you're able to see the transaction, but you don't necessarily know who that transaction is pinned to because of the address. But as you keep getting deeper and deeper and deeper into the innovations that's coming out, I think 85 to 95% of the addresses on Bitcoin can be like found as far as a user and potential location, but you still won't be able to get like a physical name and different things of that nature. But as far as like criminal activity, they'll be able to see where the address that got the money sent to, and that's typically the address that the criminal is going to be holding because that's where the money at.
And normally if there's any criminal activity, and like he said, it is where the funds were sent, the exchange, that's where the exchange is kind of like the centralized exchange is that endpoint where you can kind of pinpoint a person. The exchange will be contacted because of anti-money laundering applications and KYC. That's when that comes into play as far as protecting those parameters.
I think we have time for one more. Maybe you can address, can cryptocurrency be part of an inheritance?
Yeah, I'll just quick, yes, you can make it a part of inheritance. You would just have to be able to create, I want to say, a basic procedure. If you have a cold storage, just be able to, in your will, just kind of have some of that stuff written down. Just really be careful with how you back up your wallets and different things of that nature. I think a couple months back, somebody had like over $1 million, but they wasn't able to access it just because they forgot things like seed phrases and passwords. So definitely be mindful of that if you want to set up an inheritance.
Great, thank you so much.
Yeah, thank you so much, Sharnesha and Khari, for sharing this valuable information with us. Would you like to tell the audience where we could find you?
You can find Kankyo on Instagram at DiscoverKyo.
Excellent. Discover KYO on Instagram. Wow. I'll tell you, Sharnesha, Khari, thank you so much. It was really great learning about blockchain and also cryptocurrency technology. From your talk about cold storage to wallets, decentralization and centralization. Wow, it was really a lot jam-packed into about 30-40 minutes there. So we are so appreciative. And on that note, it's about time, everybody. Tonight's event was sponsored by the Engineering Alumni Network, and we're dedicated to creating a strong alumni network of engaged and inspired Terps, helping alumni to develop new skills that will advance their career, and also supporting the next generation of engineering leaders. Now, throughout the year, we plan social